Okay, everyone, triangles aren't going away. This next unit is over Chapter 7, so Unit 5, Chapter 7, Unit 6, Chapter 7. I'll probably just call it by chapter name. I know that we don't use the textbook, but that way if you want to reference it in Schoology, you have that option and you know where to go. So Lesson 1, we're going to talk about Section 7.1 and Section 2, which is Pythagorean Theorem. So this deals very specifically with right triangles. Um, and so Pythagorean theorem, again, right triangles, we have our parts. We have two legs, which are the sides that are perpendicular, and then we have our hypotenuse. Um, this looks like a right isosceles. They won't always be equal, so just keep that in mind. So the biggest theorem that we'll use starting out is the Pythagorean theorem, which states that in a right triangle, if you square the length of a leg and you add that to the square of the other leg, then you get the square of the hypotenuse. So let me back up here and call this leg 1 and leg 2. All right, just to differentiate between the two. You have 1, 2 legs. It doesn't matter which one goes in where. We shorten that by calling like this side A and this side B. So we have A squared plus B squared is equal to, and then we're going to call always the hypotenuse C. Okay. So we can use that formula and just some basic algebra to solve for a missing side in a triangle. So the key thing is making sure, and you can use your right angle kind of like an arrow, making sure that your C gets plugged into the right spot. So identify or label your triangle first, and then you can set it up to solve. So in this case, we're solving for a side, not the hypotenuse. So we have A squared plus B squared equals C squared. And we can just substitute in those values. So we have x squared plus 3 squared is equal to 5 squared. And the parentheses aren't really necessary, but because every once in a while you have some addition going on in here, which would require distribution, it's just good practice to go ahead and put those in. If you were plugging in a negative, you'd also need them with side lengths. You won't have any negatives. So we have x squared plus 9 is equal to 25, and then we're just going to solve this out. So we subtract the 9 over, and we get x squared is equal to 16. And then we square root both sides. To get rid of a square, use square root. So x is equal to, and this requires you to kind of go back to algebra. Technically, the square root of x squared is a positive or a negative. So the square root of 16 is plus or minus 4. Again, because we're talking about a distance, we're going to ignore the negative. And just say that x is equal to 4. And from here on out, I will just write the positive answer. Just be aware that a negative 4 would also work in this circumstance, because that will show back up in some of your exit tickets possibly, as well as Algebra 1B. Okay, so for B, similar thing, only this time we can see, hopefully, that our C is the unknown, the x, and everything else is your A and your B. Doesn't matter which one's A, which one's B. You could do AB or you can do BA. It will get you the same result. So we plug everything in. So we have 6 squared plus 4 squared is equal to x squared. So 36 plus 16 is x squared. 52 is x squared. Again, when I take the square root of this, it's technically positive or negative, but I'm not going to worry about that. We're going to leave everything in radical form because where we're going with this is what's called right triangle trig, and we want it in the best form possible, and that's before you round. So we leave everything in radical form. What that means is we have to simplify our radicals, and we'll work a little bit more on this in class, but 52, if you look at what goes into 52, it's 4 times 13, and I picked 4 because 4 is a perfect square. So square root 52 can be rewritten as square root of 4 times the square root of 13. And the square root of 4 is just 2. So x equals 2 times the square root of 13 because that does not have a square root. So look for perfect squares that go into your number. When you're doing that. Okay, so 2 root 3 is the length of this side. 13, excuse me, 2 root 13. All right, so that's not a perfect number. It's an irrational number. If you took the square root of 13 out, you would get this big long decimal that has to be rounded. When you do get perfect whole numbers for all 3 sides, that's what's called a Pythagorean triple. Okay, so a Pythagorean triple, again, is when the 3 sides of a right triangle are integers. So this is even more specific, whole numbers. Because integers implies that they can be negative, and they can't. So the 3 sides of a right triangle are whole numbers that satisfy the Pythagorean theorem, meaning that make it true if you plug them in. So whole numbers that if you plugged into a squared plus b squared equals c squared, it would be true. The a squared and the b squared added together would be your c squared. So we have common Pythagorean triples used in construction and stuff like that. 3, 4, 5 is the most common one. You can multiply all of those by 2 and get 6, 8, 10. That is also a triple. 5, 12, 13. 8, 15, 17. 7, 24, and 25. Okay, so all these are real common. There's more listed in the book. You're welcome to memorize them, though the work to memorize them is probably just as much as just doing the workout real quick. But if you do memorize them, you don't have to show work. So if you, for example, have a 4, 3x triangle and you recognize the fact that that's a 3, 4, 5 triangle, you can just say x equals 5. You don't have to show the whole formula and plugging in and solving part. Okay. So yeah, so Pythagorean triples, we could also find missing values to make it a triple that you would need to solve out, or again have it memorized. So if I give you 6 and 8, tell me that it's 10, and so on and so forth. Okay. So we can also use an inequality. So remember, your inequalities are less than, greater than, to determine whether or not something is a right triangle or obtuse or acute. So we use that with Pythagorean theorem, and we just compare the 2 sides. So first decide if it is a triangle, okay, because sometimes you have side lengths that aren't even a triangle at all. So add your 2 smallest sides, okay, if the sum, so if that answer is greater than the third side, then it is a triangle. Okay, so for example, if I give you 5, 2, 6, all right, then 5 plus 2 equals 7, which is bigger than 6, so this is a triangle. Okay. All right, so then we can classify the triangle in terms of its angles, right? Obtuse or acute. So we find c squared, remembering that c squared is the biggest number, which is your hypotenuse. And we look for a squared plus b squared, which is the sum of the legs squared. So we use the legs for that, your two shortest sides. And we compare them. When c squared is equal to a squared plus b squared, we already know that it is a right triangle because we've already talked about Pythagorean theorem. So does it satisfy Pythagorean theorem? If so, then it is a right triangle. But if c squared is greater than a squared plus b squared, it is obtuse. And you think about obtuse being greater than 90, so that would make sense. And then the opposite of that, if c squared is less than a squared plus b squared, it is an acute triangle, meaning that your angles would all be less than 90. So less than 90, its definition of acute, c squared should be less than. Okay. All right, so how this works, 14, 48, and 50. Well, without even doing the math, I can tell that by adding the smallest two sides, it's bigger than the largest, but let's go ahead and write that out. 14 plus 48 is equal to 60, which is greater than 50. So this is a triangle. All right. So c squared is your longest side squared, which is 50 squared. So 2,500. A squared plus b squared is the sum of your shorter sides squared. So you type that in your calculator, you'll see that it's 2,500. Well, if I compare the two, 2,500 and 2,500, those are equal, so this is a right triangle. Okay, so let's try, I'm going to actually have you try B, and I'm going to jump down here to C to talk about what happens if they are still in radical form. There should be a comma here. So 9 plus 14 is 23. When comparing something to something in radical form, so we're comparing this to 7 root 5, which you would have needed to do in your calculator real quick to see that it was the longer side, so that's 15.7. 23 is obviously greater than 15.7, so this is a triangle. All right, so now we can plug everything in. So when you do 7 root 5 squared for your c squared, you're going to square the 7 and square the root of 5. Just type it in your calculator just as you see it, and you'll see that it's 245. The reason this is because it's 49 times 5. Okay. So 245, a squared plus b squared is 9 squared plus 14 squared, which is 277. So when comparing 245 to 277, I'm going to use less than, and we talked up here that less than is acute. So this is an acute triangle. Okay. And then I want you to try D on your own as well. Okay, and that's it for this one. So most of it is Pythagorean theorem, but then using that in different ways to discover and classify what type of triangle it is, to find missing sides, and then to even figure out if something is a triangle. All right? Okay, have a good night.